Hi guys, thanks for joining us. In this video, I'm going to show you how to define the output points of an SCC 520. So as you can see, the picture of 520 here. Down here we have DO1 to DO5, and basically those are your 5 relays that are on board SCC 520. They're normally open relays, normally open contact relays, and there are 5 of them. Also, you have 3 analog outputs. They're labeled AO6, AO7, and AO8. Now, these analog outputs are 0 to 10 volt analog outputs, and we'll cover how you would define all this stuff in the Catalyst programming tool. Okay, so let's go into the Catalyst programming tool. Okay, so we're in the backend integrator software, and I've already defined an SCC 520, so I'm going to right click on it and launch the Catalyst programming environment. And now that we're in the Catalyst environment, all the local points are defined using the hardware menu and the blocks in the hardware menu, as you can see on the left hand side. So for the outputs, the options we have are analog output as well as the digital output. So let's start with digital output. I'm just going to drag a block and bring it here. I'm just going to move it so you can see it better. By default, Catalyst uses the first output that's available, which is DO1. You can name it whatever you want. By default, it calls it DO01, which is a standard backnet name, but it can be named anything. So let's go ahead and rename it to fan on off. Something like that. Okay. And the way we configure the output, we can get into the configure button using the smart tab here or down here. I like to go from down here. It doesn't really matter what you do. When I click on the configure button, as you can see, it will give me the option to make the output normally close contact. So I can do that. When I do that, basically that means that when the relay is off, I will indicate on in the program, and when the relay is on, I will indicate off in the program. So that's all that does. You can define your minimum on-off times. Personally, I like to use the minimum on-off blocks in the program versus defining it in the output itself. But again, that's a choice that you need to make as your program preference. Okay. So that was for your relay definition example for number 1. Again, you can drag in more and you can define them as you like. Okay, so you have 5 of those that you can define. Let's drag in an analog output. Now all the analog outputs on the 520, there are 3 of them available, and they're all 0 to 10 volt. So the first one that calls it AO6. That's what's available. Again, you can go and rename it to what you want. Let's just say valve, for example. Okay, and again, I can click on configure. This is where I would define what my engineering units matches with voltage. So this gives you the option of basically throttling or limiting what you put out. So for example, if I only wanted to put out let's say at 0 I wanted to put out 2 volts, I'll make that 2, and at 100 volts I can make it 100% I can make it 7 volts, and so on. It just gives you the option of defining what you want to do. But typical ones are 0 to 10, as you can see here, or reverse, which is 10 to 0 for example, a heating valve. That's normally open. That would be very common. But again, we give you complete customization of throttling what you want to do with the voltage. Okay? So, and then you have 3 of the analog outputs. So that's as far as the outputs go. In the future, there's going to be expansion modules for the 520. So you'll have more analog outputs. You can increase the present analog outputs using the Modbus port that's available and using some Modbus I/O. So there's lots of options to expand the points if you wanted to, the hardware points. Okay. Hopefully that gives you guys an idea of how to configure the output points. If you have any questions, please call us or email us, and we'll be happy to show you anything you need to know. Thank you.